Welcome back, Applied Calculus students. In this screencast, we'll do a few more examples that use the chain rule. I want to make sure we know how to find equations of tangent lines. I want to make sure we know how to work with tabular data. In fact, let's start with tabular data. This will be example 4 because there were 3 in another screencast. And I'm just going to set up a table for 3 particular values of x for f and g and f prime and g prime, and the values are as described in the table. What I want to find is the derivative of f of g at 2. The derivative of f of g at 2. How does this work? Well, this is f of g of x, and we're looking to find its derivative when x is 2. So how do we do that? We take the derivative of the outermost layer, this is the outermost layer, leaving the inside alone, and then multiply by the derivative of the inside layer. And we're going to evaluate this when x is 2, which means we're looking to do f prime of g of 2 times g prime of 2. G of 2, that's 3, so we're looking for f prime of 3 times g prime of 2. F prime of 3 is -5. G prime of 2 is -2, and that turns out to be 10. F of g is a function, and at x equals 2, the tangent line has a slope of 10. This is something we anticipate that you will know how to do. Let's say, let's go with this. Find the equation of the tangent to y equals x to the 4th plus 2 to the 5th power at the point 1, 243. It's the equation of a line. I know how to write the equation of a line. It's y minus y1 equals x minus x1 multiplied by the slope. And that's where the formula comes from. So how do we find the slope? Well, we need a derivative. How do we find a derivative of this thing? Well, this is u to the 5th, where u is x to the 4th plus 2. So we take the derivative as if u were the variable, and then we take the derivative as if x were the variable. The chain rule says to have the actual derivative, we put these pieces together. 5u to the 4th times 4x cubed. This is u. At x equals 1, what is this? This is 5 times 3 to the 4th times 4 times 1 cubed. 3 to the 4th is 81. 81 times 20 is 1,620. That's the slope. This is the equation of the tangent line. It is a line with a very, very steep slope. Okay? Okay. Let's go one more. Find an equation of the tangent to y equals square root 2x plus 1 at 4, 3. You may want to pause for a moment, maybe hit the pause button, try to work it out yourself, come back to the video when you think you have an answer. I'll say that we know how to write the equation of a tangent. It's y minus y1 equals x minus x1 multiplied by the slope. But where do we find the slope? Slopes are derivatives. So I got to take the derivative of this thing, and the derivative of this thing is a square root. That's a 1/2 power. So the outermost layer is 1/2 times the thing to the negative 1/2 power. And then once we've handled the outside layer, we look inside. We take the derivative of the inside and multiply it there. Now the 1/2 and the 2 cancel out, and we're left with 1 over 2x plus 1 to the 1/2. Now add x equals 4. The slope of the tangent is 1 over 3. And that's the slope, and that's the equation of the tangent. The process is always the same. There's an outer layer. We find its derivative, leaving what's inside untouched. Then once the outer layer is taken care of, then we can look inside and take derivatives of what's inside. I hope this is helpful, that these are demonstrations that are helpful to you, and we will see you when you gather together in class.